What if I told you that somewhere out there, in the vast expanse of the cosmos, there's a world that could be home to life as we know it, not in the realm of science fiction, but right here in our own galaxy? This isn't just a dream, it's a reality scientists are uncovering one discovery at a time. From planets with oceans of molten lava to worlds that might harbor alien oceans beneath their icy surfaces, the universe is full of surprises that challenge everything we thought we knew. And today, we're diving into the 25 greatest discoveries about alien worlds findings that have reshaped our understanding of the cosmos and our place within it. These aren't just distant dots of light, they're windows into the possibilities of life, the extremes of nature, and the secrets of how planets form and evolve. So, buckle up as we embark on a journey through the most astonishing revelations about worlds beyond our own. And trust me, the first discovery we'll explore is going to blow your mind. What if I told you that just over 2 decades ago, we didn't know if planets existed beyond our solar system? It's hard to imagine now, but before 1995, the idea of other worlds orbiting distant stars was purely theoretical. That all changed with the discovery of 51 Pegosi B, a planet so groundbreaking it rewrote the rules of astronomy. This wasn't just any planet, it was the first exoplanet ever found orbiting a sun-like star, and its existence shattered the long-held belief that our solar system was one of a kind. Located about 50 light-years away in the constellation Pegasus, 51 Pegasi B was detected using a technique called radial velocity. Here's how it works. As a planet orbits its star, its gravitational pull causes the star to wobble ever so slightly. By measuring these tiny shifts in the star's light, astronomers could infer the presence of a planet, and what they found was astonishing: a gas giant, similar in size to Jupiter, but orbiting its star in just 4 days. That's right, a year on 51 Pegosi B lasts less than a week on Earth. This close orbit defied everything we thought we knew about how planets form and behave, sparking a revolution in planetary science. The discovery of 51 Pegosi B didn't just prove that exoplanets exist, it opened the floodgates for a new era of exploration. Suddenly, the universe felt more alive, more dynamic, and far more mysterious than we ever imagined. It showed us that planets could exist in places and ways we hadn't even considered, and it paved the way for the thousands of exoplanets we've discovered since. From scorching hot worlds to icy giants, the diversity of alien planets is staggering, and it all started with this one groundbreaking find. So, as we marvel at the incredible discoveries that followed, let's not forget the planet that started it all, 51 Pegosi B, the world that changed everything. But what if I told you that not only do planets exist beyond our solar system, but some of them might be just like Earth? Enter the TRAPPIST-1 system, a discovery so extraordinary it made headlines around the world. Picture this: a single star, smaller and cooler than our Sun, orbited by not 1, not 2, but 7 Earth-sized planets. And here's the kicker: 3 of these worlds sit snugly in the star's habitable zone, that sweet spot where temperatures could allow liquid water to exist. For scientists, this was like hitting the cosmic jackpot. Could these planets be the key to answering one of humanity's oldest questions? Are we alone in the universe? The TRAPPIST-1 system, located about 40 light-years away, was discovered using a technique called the transit method. Here's how it works. When a planet passes in front of its star, it blocks a tiny fraction of the star's light. By measuring these dips in brightness, astronomers can determine the planet's size, orbit, and even its potential atmosphere. It's like watching a shadow cross a distant light bulb and deducing the shape and speed of the object casting it. But don't let the simplicity fool you. This method requires precision and patience, as the changes in light are incredibly subtle. What makes TRAPPIST-1 so special isn't just the number of planets, but their arrangement. These worlds are packed tightly together, with orbits so close that if you stood on one planet, you might see another hanging in the sky like a giant moon. Imagine looking up and seeing not just one but multiple neighboring worlds, each with its own unique story. But with such proximity comes challenges. The star, a dim red dwarf, is prone to violent flares that could strip away atmospheres or bombard planets with radiation. Could life survive in such a harsh environment? That's the million-dollar question. The discovery of TRAPPIST-1 didn't just expand our catalogue of exoplanets, it forced us to rethink what it means for a planet to be habitable. It's not just about being the right distance from a star, it's about the interplay of atmosphere, geology, and even the star's temperament. This system is a reminder that the universe is full of surprises, and that the conditions for life might be far more diverse than we ever imagined. So, as we marvel at the possibilities of TRAPPIST-1, let's also ponder, what does it truly take for a world to support life, and could one of these 7 planets hold the answer? Now, imagine a world so close to us that it could be our cosmic next-door neighbor. Just over 4 light-years away, in the constellation of Centaurus, lies Proxima Centauri B, the closest known exoplanet to Earth. Discovered in 2016, this rocky planet orbits Proxima Centauri, a red dwarf star that's part of the Alpha Centauri star system. At just 24 light-years away, it's practically in our backyard compared to the vast distances of the cosmos. But what makes this discovery so exciting isn't just its proximity. It's the tantalizing possibility that Proxima Centauri B could be habitable. Proxima Centauri B sits within its star's habitable zone, where temperatures might allow liquid water to exist on its surface. That's a big deal because, as far as we know, water is essential for life as we understand it. But here's the catch: Proxima Centauri is a red dwarf, a type of star known for its fiery temper. These stars are smaller and cooler than our Sun, but they're also prone to violent flares that can unleash torrents of radiation. For a planet orbiting so close, Proxima Centauri B completes a year in just 11 Earth days. This could spell trouble. Could an atmosphere survive such an onslaught? And if it does, could life find a way to thrive in such a harsh environment? These are the questions scientists are racing to answer. Studying Proxima Centauri B isn't easy. Its star's flares make it difficult to observe directly, and its proximity to Earth, while close in cosmic terms, is still unimaginably far by human standards. But that hasn't stopped us from dreaming big. Enter the Breakthrough Starshot Initiative, a bold plan to send tiny, light-powered probes to the Alpha Centauri system. These probes, no bigger than a postage stamp, would be propelled by powerful lasers, reaching speeds of up to 20% the speed of light. At that pace, they could reach Proxima Centauri B in just over 20 years, sending back data that could revolutionize our understanding of this nearby world. The idea of interstellar exploration might sound like science fiction, but with initiatives like Breakthrough Starshot, it's becoming a tangible possibility. Imagine a future where we're not just observing distant planets from afar, but actively exploring them. Proxima Centauri B could be the first step in that journey, a stepping stone to the stars. So, as we ponder the mysteries of this nearby world, let's also dream of what lies ahead. Could Proxima Centauri B be the key to unlocking the secrets of life beyond Earth? And could it inspire humanity to take its first steps into the interstellar frontier? The answers might be closer than we think. What if I told you that one mission alone transformed our understanding of the universe, revealing that planets aren't just common, they're everywhere? Enter the Kepler Space Telescope, a game-changer in the hunt for alien worlds. Launched in 2009, Kepler's mission was simple yet revolutionary. Stare at a single patch of sky and watch for the telltale dips in starlight caused by planets passing in front of their stars. What it found was nothing short of extraordinary. Over its 9-year mission, Kepler confirmed the existence of more than 2,600 exoplanets worlds that range from rocky super-Earths to gas giants larger than Jupiter. But Kepler didn't just find planets, it revealed a universe teeming with them, suggesting that planets outnumber stars in our galaxy. One of Kepler's most groundbreaking discoveries was the sheer diversity of these worlds. Take super-Earths, for example, planets larger than Earth but smaller than Neptune. These worlds don't exist in our solar system, yet Kepler showed they're incredibly common elsewhere. Then there are hot Jupiters, gas giants that orbit scorchingly close to their stars, defying our expectations of how planetary systems form. And let's not forget the mini-Neptunes, planets with thick atmospheres that could hide oceans of water or even exotic forms of ice. Kepler's findings painted a picture of a galaxy filled with planets of all shapes, sizes, and compositions, a cosmic menagerie that continues to astound scientists. But perhaps Kepler's most profound contribution was its statistical significance. By meticulously cataloging thousands of planets, Kepler gave us the data to estimate just how common planets are in the Milky Way. The numbers are staggering. There could be billions of Earth-sized planets in the habitable zones of their stars, places where liquid water and potentially life could exist. This revelation didn't just change how we see the universe, it changed how we see ourselves. If planets are this abundant, the chances of finding another Earth or even life beyond our own feel more real than ever. Kepler's legacy is more than just a list of planets. It's a testament to human curiosity and ingenuity. It showed us that the universe is far more dynamic and diverse than we ever imagined, and it set the stage for future missions to build on its discoveries. But as we marvel at Kepler's achievements, let's not forget the strangest worlds it uncovered, planets that defy logic and stretch the limits of our imagination. From worlds with 2 suns to planets darker than coal, Kepler revealed a universe that's as bizarre as it is beautiful. And speaking of bizarre, our next discovery takes us to one of the strangest worlds Kepler ever found, a place where the rules of physics seem to bend. Ready to explore? Let's dive in. What if I told you there's a planet out there that might be made of diamonds? No, this isn't the plot of a sci-fi movie, it's real. Meet 55 Cancri E, a world so strange it defies imagination. Located about 40 light-years away in the constellation Cancer, this planet is one of the most exotic discoveries in the hunt for alien worlds. Scientists believe 55 Cancri E is composed largely of carbon, the same element that forms diamonds here on Earth. And under the crushing pressures and scorching temperatures of this planet, that carbon could very well have crystallized into a glittering, diamond-like surface. Imagine a world where the ground beneath your feet isn't rock or ice, but a vast, sparkling expanse of diamond. It's a treasure hunter's dream, but don't pack your bags just yet. 55 Cancri E is no paradise. This planet orbits its star so closely that a single year lasts just 18 hours. That proximity means surface temperatures can reach a blistering 2,400 degrees Celsius, hot enough to melt iron. The planet's surface is likely a molten sea of lava, with rivers of magma flowing across its diamond-rich crust. And if that weren't extreme enough, 55 Cancri E is tidally locked, meaning one side always faces its star while the other is plunged into eternal darkness. The result, a world of stark contrasts where one hemisphere is a scorching inferno and the other is a frozen, diamond-studded wasteland. But what makes 55 Cancri E truly fascinating isn't just its extreme conditions, it's what it tells us about the diversity of planets in the universe. This diamond planet challenges our assumptions about how planets form and evolve. Most planets in our solar system are made of silicates and metals, but 55 Cancri E suggests that carbon-rich worlds could be out there too. These exotic planets might form in systems where the star has a higher carbon-to-oxygen ratio, creating conditions ripe for carbon-based materials like graphite and, yes, diamonds. It's a reminder that the universe is far more creative and far stranger than we ever imagined. The discovery of 55 Cancri E also raises intriguing questions about the potential for life on such worlds. Could carbon-rich planets host unique forms of chemistry or even life that we've never encountered before? While 55 Cancri E itself is far too hostile for life as we know it, its existence opens the door to exploring other carbon-dominated worlds that might be more hospitable. It's a tantalizing thought, one that keeps scientists searching for the next big discovery. But as we marvel at the glittering enigma of 55 Cancri E, let's not forget that the universe has even more surprises in store. From diamond planets to worlds with skies of molten glass, the cosmos is full of wonders that stretch the limits of our imagination. And speaking of molten skies, our next discovery takes us to a planet so bizarre, it makes 55 Cancri E look almost ordinary. Ready to explore a world where it rains glass? Let's dive in. What if I told you there's a planet so hot, its surface is a churning ocean of molten lava? Meet Kepler 10b, a world that redefines the word extreme. Discovered in 2011 by NASA Kepler Space Telescope, this rocky planet is one of the first Earth-sized exoplanets ever found, but don't let its size fool you. Kepler 10b is a scorching inferno with surface temperatures soaring to over 1,400 degrees Celsius. That's hot enough to melt rock, turning its surface into a vast glowing sea of lava. Imagine standing on a planet where the ground beneath your feet isn't solid, but a roiling, molten expanse. It's a place where the very idea of land is turned upside down. Kepler 10b orbits its star so closely that a single year lasts just 20 hours. This proximity means the planet is tidally locked, with one side perpetually facing its star and the other shrouded in eternal darkness. The day side is a hellish landscape of molten rock, while the night side, though cooler, is still hot enough to keep any solid surface from forming. The result: a world where the concept of solid ground simply doesn't exist. Instead, Kepler 10b is a planet-wide lava ocean, a place where the rules of geology are rewritten by extreme heat and gravity. But what makes Kepler 10b truly groundbreaking isn't just its fiery surface, it's what it taught us about the diversity of rocky planets. Before its discovery, scientists assumed that Earth-sized planets would be, well, Earth-like. Kepler 10b shattered that assumption, showing us that rocky worlds can exist in environments far more extreme than anything in our solar system. This discovery challenged our understanding of planetary formation and evolution, proving that the universe is full of surprises. It also raised fascinating questions. Could planets like Kepler 10b have once been more Earth-like, only to be transformed by their proximity to their stars? Or are they born into their fiery fates, destined to be molten from the start? Studying Kepler 10b wasn't easy. Its small size and extreme conditions made it a challenging target, but astronomers used a combination of techniques to piece together its story. By analyzing the planet's density and composition, they determined that Kepler 10b is likely made of iron and silicate rock, similar to Earth but with a much higher proportion of iron. This dense, molten core gives the planet its intense gravity, which in turn shapes its fiery surface. It's a reminder that even in the most extreme environments, the laws of physics still hold sway. The discovery of Kepler 10b didn't just expand our catalogue of exoplanets, it forced us to rethink what's possible. It showed us that rocky planets can exist in conditions we once thought impossible, and it opened the door to exploring other extreme worlds. But as we marvel at the fiery enigma of Kepler 10b, let's not forget that the universe has even more surprises in store. From molten lava oceans to worlds that might harbor life, the cosmos is full of wonders that challenge our imagination. And speaking of life, our next discovery takes us to a planet that just might have the right ingredients for it, ready to explore a world where life could exist. Let's dive in. What if I told you that the search for alien life hinges on a single, seemingly simple idea, the habitable zone? This concept, often called the Goldilocks zone, is the sweet spot around a star where temperatures are just right, not too hot, not too cold, for liquid water to exist on a planet's surface. And since water is essential for life as we know it, finding planets in this zone has become the holy grail of exoplanet research. But here's the twist: the habitable zone isn't as straightforward as it sounds. It's a dynamic, ever-shifting region that depends on a star's size, temperature, and even the planet's atmosphere. So, how do we use this concept to guide our search for potentially habitable worlds? And what happens when we find a planet that seems to fit the bill? Let's dive in. The habitable zone isn't a fixed distance from a star, it's more like a moving target. For a star like our Sun, the zone stretches roughly from Venus's orbit to Mars's orbit. But for smaller, cooler stars like red dwarfs, the habitable zone is much closer in. That's because these stars emit less heat, so planets need to huddle closer to stay warm enough for liquid water. On the flip side, planets orbiting larger, hotter stars have to stay farther away to avoid being scorched. This variability means that the habitable zone is different for every star system, making the search for Earth-like worlds both thrilling and complex. One of the most exciting discoveries in this quest is Kepler 452 b, often called Earth's cousin. Located about 1,400 light-years away, this planet orbits a star very similar to our Sun, and it sits comfortably within its star's habitable zone. Kepler 452 b is about 60% larger than Earth, and its year lasts 385 days, just a bit longer than ours. Scientists believe it could have a rocky surface and even a thick atmosphere, making it one of the most Earth-like planets we've found so far. But here's the catch: we don't know for sure if Kepler 452 b has water or an atmosphere. Without direct observations, it's hard to say whether this world is truly habitable or just a tantalizing possibility. The habitable zone concept has been a game-changer in exoplanet research, but it's not without its limitations. Just because a planet is in the right spot doesn't mean it's a paradise. Take Venus, for example. It's technically within our Sun's habitable zone, but its thick, toxic atmosphere traps heat, turning it into a scorching hellscape. On the other hand, some planets outside the traditional habitable zone might still have liquid water thanks to internal heat sources or greenhouse effects. This complexity reminds us that habitability isn't just about location, it's about a delicate balance of factors, from atmosphere to geology to the star's behavior. So, what happens when we find a planet that pushes the boundaries of the habitable zone? Enter Proxima Centauri B, a world we've already touched on. This rocky planet orbits a red dwarf star, and while it's in the habitable zone, its star's violent flares could make life a challenge. Yet, scientists haven't ruled out the possibility of habitability. Could Proxima Centauri B have a protective magnetic field or a thick atmosphere that shields it from radiation? These are the questions that keep astronomers up at night, and they highlight the evolving nature of the habitable zone concept. The search for habitable worlds is far from over, and each discovery brings us closer to answering one of humanity's biggest questions: are we alone? As we continue to explore the cosmos, the habitable zone remains a crucial tool, but it's also a reminder that the universe is full of surprises. And speaking of surprises, our next discovery takes us to a world that defies even the most basic assumptions about habitability. Ready to explore a planet where the rules of life might be rewritten? Let's dive in. What if I told you there's a planet where the sun never sets or rises? Imagine a world where one side is forever bathed in scorching daylight, while the other is locked in eternal night. This isn't science fiction. It's the reality of tidally locked planets, a phenomenon that's as fascinating as it is extreme. These worlds are so close to their stars that gravity has essentially frozen their rotation, leaving one hemisphere perpetually facing the star and the other shrouded in darkness. The result, a planet of stark contrasts where the day side can be a blazing inferno and the night side a frozen wasteland. But here's the twist: in the twilight zone between these extremes, life might just find a way to thrive. Take Proxima Centauri B, for example. This rocky planet, orbiting the closest star to our Sun, is tidally locked. Its day side faces its red dwarf star, enduring relentless heat and radiation, while the night side is plunged into freezing darkness. But in the narrow band between these two extremes, the twilight zone conditions might be just right for liquid water to exist. This region could have a stable climate with temperatures that aren't too hot or too cold, creating a potential haven for life. It's a tantalizing thought. Could this twilight zone be home to unique ecosystems, adapted to the constant balance of light and shadow? The idea of life on a tidally locked planet challenges our Earth-centric view of habitability. On Earth, life thrives on the cycle of day and night, but on a tidally locked world, life would have to adapt to a very different rhythm. Plants, for example, might grow sideways, stretching toward the eternal twilight, while animals could evolve to migrate between the warmer and cooler regions. It's a reminder that life is incredibly resilient and creative, capable of finding a foothold in even the most extreme environments. But studying tidally locked planets isn't easy. Their unique orientation makes it difficult to observe their atmospheres and surface conditions directly. Astronomers have to rely on indirect methods, like measuring the heat emitted from the day side or analyzing the faint light reflected from the night side. These observations are painstaking, but they're crucial for understanding whether these worlds could truly support life. And with new telescopes like the James Webb Space Telescope, we're getting closer to answering these questions. The discovery of tidally locked planets has expanded our understanding of what makes a world habitable. It's not just about being in the right place, it's about how a planet interacts with its star, its atmosphere, and even its own geology. These worlds remind us that the universe is full of possibilities, and that life might exist in forms and places we've never imagined. But as we ponder the mysteries of tidally locked planets, let's not forget that the cosmos has even more surprises in store, like the incredible diversity of planetary atmospheres. From worlds with skies of molten glass to planets with air made of diamonds, the universe is a place of endless wonder, ready to explore. Let's dive in. What if I told you that we've not only found planets beyond our solar system, but we've also peered into their skies? That's right, scientists have detected the atmospheres of alien worlds, and it all started with a planet called HD 209,458 b. This discovery wasn't just a milestone, it was a revolution. For the first time, we weren't just looking at distant dots of light, we were studying the very air of another world. And what we found was as surprising as it was groundbreaking. HD 209,458 b, a gas giant located about 150 light-years away, is what astronomers call a hot Jupiter. It's a massive planet, similar in size to Jupiter, but it orbits its star so closely that its surface temperatures soar to over 1,000 degrees Celsius. But what made this planet truly special wasn't its size or its scorching heat. It was the fact that in 2001, scientists detected its atmosphere. This was the first time an exoplanet's atmosphere had ever been observed, and it opened up a whole new frontier in planetary science. So how did they do it? The key was a technique called spectroscopy. Here's how it works. When a planet passes in front of its star, some of the star's light filters through the planet's atmosphere. Different gases in the atmosphere absorb specific wavelengths of light, creating a unique fingerprint. By analyzing these fingerprints, scientists can determine what the atmosphere is made of. In the case of HD 209,458 b, they found evidence of sodium, hydrogen, carbon, and even water vapor. Yes, water, on a planet where the surface is hot enough to melt metal. This discovery was a game changer. For the first time, we had a glimpse into the chemical makeup of an alien world, and it showed us that the techniques used to study Earth's atmosphere could be applied to planets light years away. But HD 209,458b wasn't just a scientific curiosity, it was a stepping stone. By proving that we could detect and analyze exoplanet atmospheres, this discovery paved the way for studying smaller, potentially habitable planets. Imagine being able to study the air of a distant Earth-like world, searching for signs of oxygen, methane, or even life itself. That's the power of this breakthrough. But HD 209,458b didn't just reveal the potential of spectroscopy, it also gave us a glimpse into the wild diversity of planetary atmospheres. This hot Jupiter's atmosphere is nothing like what we see in our solar system. It's a swirling, turbulent mix of gases with winds that can reach speeds of 7,000 kilometers per hour. And because the planet is so close to its star, its atmosphere is literally being blown away, creating a comet-like tail of gas. It's a reminder that the universe is full of worlds that defy our expectations, each with its own unique story to tell. The detection of HD 209,458b's atmosphere was a turning point in our quest to understand the cosmos. It showed us that we're not just limited to studying planets from afar, we can explore their skies too. And as our telescopes become more advanced, the possibilities are endless. Speaking of advanced telescopes, our next discovery takes us to a world that showcases the incredible power of these instruments. A planet so strange, it's rewriting the rules of planetary science. Ready to explore? Let's dive in. What if I told you that we've just unlocked a new way to see the universe, one that lets us peer into the atmospheres of distant worlds with unprecedented clarity? Enter the James Webb Space Telescope, or JWST, a marvel of modern engineering that's already rewriting the rules of astronomy. Launched in December 2021, this telescope isn't just an upgrade, it's a revolution. With its massive gold-coated mirror and cutting-edge instruments, JWST can capture light from the earliest galaxies, study the birth of stars, and most excitingly, analyze the atmospheres of exoplanets in stunning detail. And its first findings, they're nothing short of extraordinary. One of JWST's earliest targets was WASP-96b, a gas giant located about 1,150 light-years away. This planet, classified as a hot Jupiter, orbits its star so closely that its surface temperatures reach a scorching 700 degrees Celsius. But what made WASP-96b a perfect candidate for JWST wasn't its heat, it was its atmosphere. Using its near-infrared spectrograph, JWST detected water vapor, clouds, and even haze in the planet's skies. This wasn't just a snapshot, it was a full-blown chemical analysis of an alien world's atmosphere, something that would have been impossible just a few years ago. Here's how it works. As WASP-96b passes in front of its star, some of the star's light filters through the planet's atmosphere. Different gases absorb specific wavelengths of light, creating a unique fingerprint. JWST instruments are so sensitive that they can detect these fingerprints with incredible precision, revealing not just what's in the atmosphere, but how those elements are distributed. In the case of WASP-96b, the data showed a complex mix of water vapor, clouds, and haze, a far cry from the simple, uniform atmospheres we once imagined for hot Jupiters. But JWST capabilities go far beyond hot Jupiters. Its real potential lies in studying smaller, rocky planets' worlds that could be more Earth-like. Imagine being able to detect oxygen, methane, or even signs of life in the atmosphere of a distant exoplanet. That's the promise of JWST. By analyzing the chemical makeup of these atmospheres, scientists hope to find biosignatures, indicators that life might exist. It's a tantalizing possibility, and one that's closer than ever thanks to this groundbreaking telescope. The implications of JWST findings are profound. For the first time, we're not just guessing what alien worlds might be like, we're seeing them in incredible detail. This telescope is giving us a front-row seat to the diversity of planets in our galaxy, from scorching gas giants to potentially habitable rocky worlds. And with each new discovery, we're inching closer to answering one of humanity's oldest questions. Are we alone in the universe? But JWST isn't just a tool for discovery, it's a reminder of how far we've come. Just a few decades ago, the idea of studying the atmospheres of distant planets was pure science fiction. Today, it's a reality, thanks to the ingenuity and determination of scientists and engineers around the world. And as JWST continues to explore the cosmos, who knows what other surprises it might uncover? From the first galaxies to the potential for life beyond Earth, this telescope is opening doors we didn't even know existed. So, as we marvel at the incredible findings from JWST, let's also reflect on what they mean for the future. Every new discovery brings us closer to understanding our place in the universe and to answering the question that has fascinated us for centuries: is there life out there? With JWST leading the way, the answer might be closer than we think. And speaking of life, our next discovery takes us to a world that just might have the right ingredients for it. Ready to explore a planet that could be a true Earth twin? Let's dive in. What if I told you there's a planet out there that might be one giant ocean? Meet GJ1214 B, a super-Earth that's unlike anything in our solar system. Located about 40 light-years away, this mysterious world is shrouded in a thick, steamy atmosphere, and scientists believe it could be hiding a global ocean beneath its clouds. Imagine a planet where the entire surface is covered in water. No continents, no islands, just an endless expanse of ocean stretching as far as the eye can see. It's a water world straight out of science fiction, but GJ1214 B is very real, and it's raising some fascinating questions about the potential for life in such an alien environment. GJ1214 B is classified as a super-Earth, meaning it's larger than our planet but smaller than Neptune. What makes it so intriguing is its atmosphere, which is so dense and hazy that it's nearly impossible to see through. This thick blanket of gas could be made up of water vapor, hydrogen, or even exotic compounds we've never encountered before. But here's the kicker: beneath that atmosphere, scientists suspect there might be a vast planet-wide ocean. If that's the case, GJ1214 B could be a water world unlike anything we've ever imagined. A place where the ocean is so deep it could reach hundreds of kilometers below the surface. Studying GJ1214 B isn't easy. Its thick atmosphere makes it difficult to determine what's really going on beneath the clouds. Scientists have used techniques like transmission spectroscopy, which analyzes the light filtering through the planet's atmosphere to try to piece together its composition. But even with advanced tools, GJ1214 B remains a mystery. Is it truly a water world, or could it be something even stranger? The possibilities are endless, and that's what makes this planet so exciting. But let's take a step back and think about what a water world like GJ1214 B could mean for the search for life. On Earth, water is essential for life as we know it, so finding a planet with so much of it is a big deal. But here's the twist: life on GJ1214 B, if it exists, would have to adapt to a very different environment. Imagine an ocean so deep that the pressure at the bottom is crushing, or a world where the surface is constantly shrouded in thick, steamy clouds. Could life thrive in such extreme conditions? And if so, what would it look like? These are the questions that keep scientists up at night. The discovery of GJ1214 B also challenges our assumptions about how planets form and evolve. In our solar system, we have rocky planets like Earth and gas giants like Jupiter, but nothing quite like GJ1214 B. This water world suggests that planets can exist in a wide range of compositions, from rocky to gaseous to something in between. It's a reminder that the universe is full of surprises, and that the diversity of planets out there is far greater than we ever imagined. So, as we marvel at the mysteries of GJ 1214b, let's also ponder what it means for our understanding of the cosmos. Could this water world be home to life, or is it a reminder of how unique Earth truly is? Either way, GJ 1214b is a testament to the incredible diversity of planets in our galaxy. And speaking of diversity, our next discovery takes us to a planetary system that defies all expectations, a place where the rules of planetary formation seem to have been thrown out the window. Ready to explore a system that's rewriting the textbooks? Let's dive in. What if I told you there's a type of planet that doesn't belong to any star? Imagine a world drifting alone through the cold, dark void of space. No sunrises, no sunsets, just endless night. These are rogue planets, and they are some of the most mysterious objects in the universe. Unlike the planets in our solar system, which orbit the sun, rogue planets are nomads untethered from any star. They wander the galaxy, free-floating and often invisible to our telescopes. But here's the twist: these lonely worlds might not be as lifeless as they seem. In fact, some scientists believe they could be hiding secrets that challenge everything we thought we knew about where life can exist. Rogue planets are thought to form in one of two ways. Some are born from collapsing clouds of gas and dust, just like stars, but they never grow large enough to ignite nuclear fusion. Others are ejected from their home solar systems, flung into the void by gravitational interactions with other planets or passing stars. Once adrift, these planets become nearly impossible to detect. Without a star to illuminate them, they're shrouded in darkness, making them invisible to traditional methods of observation. So, how do we find them? The answer lies in a technique called gravitational microlensing. Here's how it works. When a rogue planet passes in front of a distant star, its gravity bends and magnifies the star's light, creating a brief but detectable flash. This flash is like a cosmic fingerprint, revealing the presence of an otherwise invisible world. It's a painstaking process, requiring precise measurements and a lot of patience, but it's how we've discovered dozens of rogue planets so far. And each discovery is a reminder that the universe is full of surprises. But what makes rogue planets so fascinating isn't just how we find them, it's what they might be hiding. Some scientists believe these lonely worlds could have subsurface oceans, kept liquid by the heat generated from radioactive decay or tidal forces. If that's the case, rogue planets could be potential havens for life, even in the absence of a star. Imagine a planet with a thick, icy shell hiding a warm, watery ocean beneath. Could life exist in such an environment? It's a tantalizing possibility, and one that challenges our Earth-centric view of habitability. The discovery of rogue planets has also forced us to rethink how planets form and evolve. If these worlds can exist without a star, what does that mean for our understanding of planetary systems? Are rogue planets more common than we thought? And could they play a role in seeding life across the galaxy? These are the questions that keep astronomers up at night, and they highlight just how much we still have to learn about the cosmos. But as we marvel at the mysteries of rogue planets, let's not forget the role of technology in these discoveries. From gravitational microlensing to advanced telescopes, our ability to detect these elusive worlds is a testament to human ingenuity. And speaking of technology, our next discovery takes us to a breakthrough that's revolutionizing how we explore the universe, a tool that's giving us a clearer picture of the cosmos than ever before. Ready to dive in? Let's go. What if I told you that some of the most groundbreaking discoveries about alien worlds weren't made by professional astronomers, but by everyday people like you and me? That's right, citizen scientists, armed with nothing more than curiosity and a computer, have played a huge role in the hunt for exoplanets. projects like planet hunters have turned the search for distant worlds into a global team effort, proving that you don't need a PhD to make a cosmic breakthrough. And the results, they've been nothing short of extraordinary. Planet Hunters, a project launched in 2010, invites anyone with an internet connection to sift through data from NASA Kepler Space Telescope. The goal, to spot the telltale dips in starlight that signal a planet passing in front of its star. It's a task that requires a keen eye and a lot of patience, but it's also one that computers sometimes struggle with. That's where human intuition comes in. Citizen scientists have proven to be incredibly good at spotting patterns that algorithms might miss, and their contributions have led to some truly remarkable discoveries. One of the most famous examples is the discovery of Cancri 8,462,852, also known as Tabby's star. This star, located about 1,400 light-years away, made headlines when citizen scientists noticed something strange. Its light was dimming in irregular, dramatic ways. Professional astronomers were baffled. Was it a swarm of comets, a massive alien megastructure? While the mystery remains unsolved, the discovery of Tabby's star wouldn't have happened without the sharp eyes of citizen scientists. It's a reminder that sometimes the most important breakthroughs come from unexpected places. But Tabby's star is just the beginning. Citizen scientists have helped identify dozens of exoplanets, including some that are truly unique. Take PH1, for example, a planet discovered by a retired schoolteacher and a small group of volunteers. PH1 is a circumbinary planet, meaning it orbits not one but two stars. Imagine a world with two suns in its sky, a place where sunsets and sunrises would be a daily spectacle. It's a discovery that wouldn't have been possible without the dedication of amateur astronomers. The impact of citizen science goes beyond individual discoveries. By involving the public in the search for exoplanets, projects like Planet Hunters have accelerated research and expanded our understanding of the cosmos. They've also made science more accessible, showing that anyone can contribute to the quest for knowledge. It's a powerful reminder that the universe belongs to all of us and that we all have a role to play in exploring it. But perhaps the most exciting part of this story is what it means for the future. As technology advances and more data becomes available, the role of citizen scientists is only going to grow. Imagine a world where millions of people are actively involved in the search for alien worlds, each contributing their unique perspective and skills. It's a vision of collaboration that could transform how we explore the cosmos, bringing us closer to answering one of humanity's biggest questions: are we alone? So, as we celebrate the incredible contributions of citizen scientists, let's also reflect on what they teach us about the power of teamwork. From spotting distant planets to solving cosmic mysteries, these everyday explorers are proving that the universe is a place where anyone can make a difference. And speaking of teamwork, our next discovery takes us to a groundbreaking mission that's bringing together scientists from around the world to explore one of the most intriguing places in our solar system. Ready to dive in? Let's go! What if I told you that we've found a world that could be the closest thing to Earth we've ever discovered? Meet Kepler 186f, the first Earth-sized planet ever found in the habitable zone of its star. This discovery, announced in 2014, was a game-changer, a moment that made us all wonder, could this be the place where life exists beyond our solar system? Kepler 186f isn't just another exoplanet. It's a tantalizing glimpse of what might be possible in the cosmos. But what makes this planet so special, and why has it captured the imagination of scientists and dreamers alike? Let's dive in. Kepler 186f orbits a red dwarf star about 500 light-years away in the constellation Cygnus. What sets it apart is its size, just 10% larger than Earth, and its location in the habitable zone where temperatures could allow liquid water to exist. That's a big deal because, as far as we know, water is essential for life. But here's the catch: Kepler 186f isn't a twin of Earth. Its star is much cooler and dimmer than our Sun, meaning the planet receives only about a third of the sunlight we do. Imagine a world where the sky is always a dusky red, and the days are dimmer than a cloudy afternoon on Earth. It's a place that's both familiar and alien, a world that challenges our assumptions about what makes a planet habitable. Studying Kepler 186f isn't easy. At 500 light-years away, it's too distant for us to directly observe its surface or atmosphere. Instead, scientists rely on indirect methods, like measuring the planet's size and orbit, to piece together its story. What they've found is fascinating. Kepler 186f is likely a rocky planet, similar in composition to Earth, but its atmosphere, if it has one, remains a mystery. Could it be thick and protective like Earth's, or thin and tenuous like Mars's? The answer could determine whether this world is a potential haven for life or a barren, inhospitable rock. The discovery of Kepler 186f sparked a wave of excitement because it showed us that Earth-sized planets in the habitable zone aren't just possible, they're out there. It was a reminder that the universe is full of possibilities, and that the search for life isn't limited to worlds that look exactly like ours. But it also raised important questions. What does it take for a planet to truly be habitable? Is it just about being the right size and distance from a star, or are there other factors at play? These are the questions that keep scientists searching, and they highlight the complexity of finding life beyond Earth. Kepler 186f also played a key role in inspiring further exploration. Its discovery showed that the tools and techniques we've developed, like the Kepler Space Telescope, are capable of finding Earth-like worlds even in the vastness of space. It gave us hope that we might one day find a planet that's not just Earth-sized, but Earth-like in every way. And as we continue to explore, each new discovery brings us closer to answering one of humanity's biggest questions: are we alone? But as we marvel at the possibilities of Kepler 186f, let's not forget that the universe is full of surprises. Just when we think we've figured out the rules of planetary systems, we find a discovery that turns everything on its head. And speaking of surprises, our next discovery takes us to a planetary system that defies all expectations, a place where the rules of planetary formation seem to have been thrown out the window. Ready to explore a system that's rewriting the textbooks? Let's dive in. What if I told you there's a planet out there with not one, not two, but 3 suns in its sky? Imagine a world where sunsets and sunrises are a daily spectacle, with multiple stars painting the horizon in a dazzling display of light. This isn't science fiction, it's real. Welcome to the strange and fascinating realm of multi-star systems, where planets orbit not just one star, but 2 or even 3. These systems, like the famous Kepler 16b, often compared to Tatooine from Star Wars, are rewriting the rules of planetary science. But how do planets form and survive in such chaotic environments? And what does it mean for the possibility of life? Let's dive in. Kepler 16b, discovered in 2011, was the first confirmed planet orbiting a binary star system, a pair of stars that dance around each other in a cosmic waltz. This gas giant, located about 245 light-years away, orbits both stars, completing a year in just 229 Earth days. But here's the twist: because the stars themselves orbit each other, the planet experiences a constantly shifting sky. One moment, it might bask in the light of both stars; the next, it could be plunged into the shadow of one. It's a dynamic, ever-changing environment that challenges our understanding of how planets form and evolve. But Kepler 16b isn't the only multi-star system out there. Take HD 131399 AB, for example, a planet in a triple-star system. This world, located about 340 light-years away, orbits one star while 2 others dance in the distance. Depending on the time of year, the planet might experience continuous daylight or a sky filled with multiple suns. It's a scenario straight out of a sci-fi movie, but it's very real. And it raises some fascinating questions. How do planets even form in such chaotic systems? And could they ever be habitable? The answer lies in the complex dynamics of multi-star systems. When stars orbit each other, their gravitational pull creates a swirling, unstable environment. For a planet to form, it has to navigate this cosmic obstacle course, avoiding being torn apart or flung into space. But if it succeeds, the result is a world unlike anything in our solar system. These planets often have highly elliptical orbits, swinging close to their stars before drifting far away. This creates extreme temperature swings from scorching heat to freezing cold, making habitability a challenge. But here's the kicker: some scientists believe that life might still find a way. In systems with multiple stars, the combined light and heat could create stable regions where liquid water might exist. Imagine a planet orbiting just the right distance from its stars, with a climate that's neither too hot nor too cold. It's a tantalizing possibility, and one that keeps astronomers searching for more multi-star systems. Detecting planets in these complex environments isn't easy. Traditional methods like the transit technique become much harder when multiple stars are involved. Instead, scientists rely on a combination of techniques, including radial velocity and direct imaging, to piece together the puzzle. It's a painstaking process, but the results are worth it. Each new discovery gives us a glimpse into the incredible diversity of planetary systems and reminds us that the universe is far stranger than we ever imagined. So, as we marvel at the wonders of multi-star systems, let's also reflect on what they teach us about the cosmos. These worlds challenge our assumptions, push the boundaries of science, and inspire us to keep exploring. But the universe isn't done surprising us yet. From planets with 3 suns to worlds that defy even the most basic laws of physics, the cosmos is full of extremes. And speaking of extremes, our next discovery takes us to a planet so bizarre, it makes multi-star systems look almost ordinary, ready to explore a world where the rules of nature are turned upside down. Let's dive in. What if I told you there's a planet so hot it's literally hotter than some stars? Meet Kepler B, a world that redefines the word extreme. With surface temperatures soaring above 4,000 degrees Celsius, this planet is so scorching that it's breaking records and rewriting the rules of planetary science. Located about 650 light-years away, Kepler B is a gas giant orbiting a star twice as hot as our Sun. But here's the kicker: this planet is so close to its star that it completes an entire orbit in just 36 hours. That's right, a year on Kepler B lasts less than 2 Earth days, and in that time, it's being blasted with so much heat that its atmosphere is literally boiling away into space. It's a world where the very idea of extreme takes on a whole new meaning. So, how does a planet get this hot? The answer lies in its star, Kepler, a blue giant that's one of the hottest stars known to host a planet. This star emits intense ultraviolet radiation, bombarding Kepler B with energy and heating its atmosphere to unimaginable levels. In fact, the planet's day side is so hot that molecules like water and carbon dioxide can't even form. They're torn apart by the sheer heat. It's a place where the rules of chemistry are turned upside down, and where the very building blocks of life as we know it can't survive. But here's the twist: despite its hellish conditions, Kepler B is teaching us invaluable lessons about the diversity of planets in the universe. The discovery of Kepler B was a game changer because it showed us just how extreme planets can get. Before this, scientists had never imagined a world could be hotter than some stars. But Kepler B proved that the universe is full of surprises, and that planets can exist in environments we once thought impossible. It also raised fascinating questions. How do planets like this form, and what happens to them over time? Because Kepler b is losing its atmosphere at an astonishing rate, scientists estimate it could eventually be stripped down to its core, leaving behind nothing but a barren, rocky remnant. It's a reminder that even the most extreme worlds have a story to tell, and that story is still unfolding. But Kepler b isn't just a scientific curiosity, it's a window into the incredible diversity of exoplanets. From scorching hot worlds to icy giants, the universe is full of planets that challenge our assumptions and push the boundaries of what we thought was possible. And as we continue to explore, each new discovery brings us closer to understanding the full spectrum of planetary possibilities. But as we marvel at the extremes of Kepler b, let's not forget that the search for life isn't just about finding Earth-like worlds, it's about understanding the full range of environments where life might exist. And speaking of life, our next discovery takes us to a world that just might have the right ingredients for it, ready to explore a planet that could be a true Earth twin. Let's dive in. What if I told you that one of the most intriguing clues about life beyond Earth might be hiding in the thin, dusty air of Mars? It's a clue so subtle yet so significant that it sparked decades of debate and inspired missions worth billions of dollars. That clue, methane. Yes, methane, a gas we often associate with cows and landfills here on Earth. But on Mars, it's a mystery that could rewrite everything we thought we knew about the red planet. So, why is methane such a big deal? And what does it mean for the possibility of life past or present on Mars? Let's dive into the methane mystery. Methane is a simple molecule made up of one carbon atom and 4 hydrogen atoms. On Earth, it's produced by living organisms like microbes in wetlands or the digestive systems of animals. But it can also be created through geological processes like volcanic activity or chemical reactions in rocks. So, when scientists first detected methane in Mars' atmosphere back in 2003, it was a bombshell. Could this gas be a sign of life, or was it just the result of non-biological processes? The answer could change everything. The detection of methane on Mars wasn't a one-time event. Over the years, multiple missions including NASA Curiosity rover and the European Space Agency's Mars Express orbiter have picked up traces of the gas. But here's the twist: the methane doesn't stick around. It appears sporadically in small bursts and then vanishes. This has led to some fascinating theories. One possibility is that the methane is being produced underground, perhaps by microbial life, and then seeping to the surface in intermittent plumes. Another is that it's being released from ancient reservoirs trapped in the planet's crust. Either way, the mystery has only deepened with each new discovery. But interpreting these findings isn't easy. Mars' atmosphere is incredibly thin, and methane breaks down quickly when exposed to sunlight. That means any methane we detect must have been released relatively recently, within the last few hundred years at most. This raises even more questions. If the methane is being produced today, what's causing it? Could there be active geological processes or even microbial life lurking beneath the surface? The answers could have profound implications for our understanding of Mars and our search for life beyond Earth. The methane mystery has also fueled a wave of new missions to the red planet. NASA Perseverance rover, which landed in 2021, is equipped with instruments designed to study the planet's atmosphere and geology in unprecedented detail. Meanwhile, the European Space Agency's ExoMars rover, set to launch in the coming years, will carry a drill capable of reaching deep beneath the surface, where methane-producing microbes, if they exist, might be hiding. These missions are part of a global effort to solve the methane puzzle and uncover the secrets of Mars. But as we search for answers, it's worth remembering that the methane mystery isn't just about Mars. It's about the broader question of life in the universe. If methane on Mars turns out to be a sign of life, it would be the first concrete evidence that we're not alone. And even if it's not, the discovery would still tell us something profound about the planet's history and potential for habitability. Either way, the methane mystery is a reminder that the universe is full of surprises and that the search for life often leads us to unexpected places. Speaking of unexpected places, our next discovery takes us to a world that defies all expectations. A place where the potential for life might exist in one of the most extreme environments imaginable. Ready to explore a world that's as strange as it is fascinating? Let's dive in. What if I told you that some of the most mysterious worlds in the universe aren't fiery infernos or glittering diamonds, but icy giants cloaked in frigid mystery? Meet the ice giants, planets like Uranus and Neptune, but not in our solar system. These distant worlds, with their swirling atmospheres of hydrogen, helium, and methane, are some of the most enigmatic discoveries in the hunt for alien worlds. And while they might not get as much attention as their rocky or gas giant cousins, ice giants hold the key to unlocking some of the biggest questions about how planets form and evolve. So, what makes these icy worlds so special, and why are they so hard to study? Let's dive in. Ice giants are a unique class of planets, distinct from both rocky worlds like Earth and gas giants like Jupiter. They're smaller than gas giants but larger than rocky planets, with thick atmospheres dominated by ices, not just water ice, but compounds like methane, ammonia, and even hydrocarbons. These ices give ice giants their signature blue hues, as methane in their atmospheres absorbs red light and reflects blue. But beneath those stunning exteriors lies a world of extremes. Deep within an ice giant, pressures are so intense that these ices might exist in exotic states, like supersonic water, a form of water that's both solid and liquid at the same time. It's a place where the rules of physics as we know them are pushed to their limits. Studying ice giants in other star systems isn't easy. These planets are often far from their stars, making them difficult to detect using traditional methods like the transit technique. Instead, scientists rely on a combination of techniques, including radial velocity and direct imaging, to spot these distant worlds. One of the most famous examples is Kepler 421 b, an ice giant located about 1,000 light-years away. This planet, which takes an astonishing 740 days to orbit its star, is one of the coldest exoplanets ever discovered. Its discovery gave us a rare glimpse into the outer reaches of planetary systems, where ice giants like Uranus and Neptune might be more common than we thought. But why are ice giants so important? For one, they're thought to be a crucial piece of the puzzle in understanding how planetary systems form. In our own solar system, Uranus and Neptune are believed to have formed closer to the Sun before migrating outward, a process that might have shaped the entire architecture of our planetary neighborhood. By studying ice giants in other star systems, scientists can test these theories and learn more about the forces that shape planetary systems. Ice giants also offer a window into the chemistry of the early universe, as their icy compositions are thought to reflect the building blocks of planets. Yet, despite their importance, ice giants remain some of the least understood planets in the universe. Their distant orbits and faint signatures make them challenging targets for observation, and their complex atmospheres are difficult to model. But with new telescopes like the James Webb Space Telescope, we're getting closer to unraveling their secrets. These instruments allow us to peer into the atmospheres of distant ice giants, analyzing their composition and structure in unprecedented detail. And with each new discovery, we're learning more about the incredible diversity of planets in the cosmos. But as we marvel at the mysteries of ice giants, let's not forget that the universe has even more surprises in store. From icy worlds to planets that defy even the most basic laws of physics, the cosmos is full of extremes. And speaking of extremes, our next discovery takes us to a groundbreaking technique that's revolutionizing how we explore the universe, a tool that's giving us a clearer picture of the cosmos than ever before. Ready to dive into the power of gravitational microlensing? Let's go. What if I told you there's a way to find planets so distant, so faint, that they're practically invisible to traditional telescopes? Enter gravitational microlensing, a cosmic trick of light and gravity that's revolutionizing how we discover alien worlds. This technique doesn't rely on a planet's brightness or its orbit around a star. Instead, it uses the universe itself as a magnifying glass, bending the fabric of space-time to reveal hidden worlds. But how does it work, and what makes it so powerful in the hunt for exoplanets, especially those elusive rogue planets drifting alone in the void? Let's dive into the microlensing method and uncover its secrets. Here's the basic idea. When a massive object like a star or even a planet passes in front of a more distant star, its gravity bends and magnifies the light from the background star, creating a temporary brightening. This effect, predicted by Einstein's theory of general relativity, is called gravitational microlensing. For a brief moment, the foreground object acts like a cosmic magnifying glass, amplifying the light of the background star. And if that foreground object has a planet orbiting it, or if it's a rogue planet itself, the planet's gravity can create an additional, smaller spike in brightness. By carefully analyzing these spikes, astronomers can detect planets that would otherwise be invisible. One of the biggest advantages of microlensing is its ability to find planets that other methods can't. Unlike the transit method, which requires a planet to pass directly in front of its star, or the radial velocity method, which relies on a star's wobble, microlensing can detect planets at much greater distances, even those that don't orbit a star at all. This makes it perfect for finding rogue planets, those lonely nomads drifting through the galaxy untethered to any star. In fact, microlensing has already uncovered dozens of these free-floating worlds, some of which might even have the potential to harbor life beneath icy surfaces. But microlensing isn't without its challenges. The events are rare and unpredictable, requiring constant monitoring of millions of stars to catch them in action. And because each event lasts only a few days or weeks, astronomers have to act fast to gather data. Despite these limitations, microlensing has led to some groundbreaking discoveries. Take Ogle 2005 BLG 390 LB, for example, a cold, rocky planet nicknamed Hoth, after the icy world from Star Wars. Located about 21,000 light-years away, this planet orbits its star at a distance similar to that of Jupiter in our solar system, but its surface is a frigid -220°C. It's a reminder that planets can exist in environments far more extreme than anything in our solar system. What makes microlensing so valuable is how it complements other detection methods. While techniques like the transit method are great for finding planets close to their stars, microlensing excels at finding planets farther out, including those in the icy outer reaches of their systems. Together, these methods give us a more complete picture of the incredible diversity of planets in our galaxy. And as our telescopes and techniques improve, microlensing is poised to uncover even more hidden worlds, from rogue planets to distant Earth-like worlds. But as we marvel at the power of microlensing, let's not forget the bigger picture. Every discovery, whether it's a rogue planet or a distant ice giant, brings us closer to answering one of humanity's biggest questions: are we alone? And speaking of questions, our next discovery takes us to a world that challenges everything we thought we knew about where life can exist, a place so extreme it makes even the coldest microlensing discoveries look tame. Ready to explore a world where life might thrive in the most unexpected of places? Let's dive in. What if I told you that some of the most promising places to find life in our solar system aren't planets at all, but moons? That's right, beneath the icy surfaces of moons like Europa and Enceladus, there's growing evidence of vast hidden oceans. These aren't just puddles or lakes, we're talking about global oceans, potentially holding more water than all of Earth's seas combined. And here's the kicker: where there's liquid water, there's the potential for life. So, what do we know about these mysterious subsurface oceans, and what do they mean for our search for life beyond Earth? Let's dive in. Europa, one of Jupiter's largest moons, has been a prime candidate for harboring life ever since the Galileo spacecraft first hinted at its hidden ocean in the 1990s. This moon, slightly smaller than Earth's moon, is covered in a thick shell of ice. But beneath that icy crust, scientists believe there's a salty ocean up to 100 kilometers deep. What's more, Europa's ocean is thought to be in contact with the moon's rocky core, creating a potential hotspot for chemical reactions that could support life. Imagine hydrothermal vents on the ocean floor, similar to those in Earth's deep seas, where heat and minerals from the core mix with water, creating the perfect conditions for microbial life to thrive. But Europa isn't alone. Saturn's moon Enceladus has also captured the attention of scientists with its dramatic geysers. In 2005, NASA Cassini spacecraft spotted plumes of water vapor and ice erupting from cracks in Enceladus's icy surface. These plumes, which shoot hundreds of kilometers into space, are a telltale sign of a subsurface ocean. Even more exciting, Cassini detected organic molecules, the building blocks of life, in these plumes. It's as if Enceladus is giving us a sneak peek into its hidden ocean, offering tantalizing clues about what might lie beneath. So, what makes these subsurface oceans so special? For one, they're shielded from the harsh radiation and extreme temperatures of space by their icy shells. This makes them potentially stable environments where life could exist, even in the absence of sunlight. Instead of relying on photosynthesis as life does on Earth, organisms in these oceans might use chemical energy from hydrothermal vents or other sources. It's a completely different model for habitability, one that expands our understanding of where life might thrive. But studying these hidden oceans isn't easy. Their icy surfaces are incredibly thick, making it difficult to probe what lies beneath. That's where future missions come in. NASA Europa Clipper, set to launch in the coming years, will conduct detailed reconnaissance of Europa's ice shell and ocean. It will map the moon's surface, measure the thickness of its ice, and even analyze the composition of its plumes. Meanwhile, concepts for missions to Enceladus are also being explored, with proposals to fly through its plumes and directly sample the ocean below. These missions could revolutionize our understanding of these icy worlds and potentially answer the question of whether life exists beyond Earth. The discovery of subsurface oceans on Europa and Enceladus has profound implications for exoplanets too. If icy moons in our own solar system can harbor hidden oceans, why not moons orbiting distant stars? In fact, some scientists believe that icy exomoons could be even more common and potentially more habitable than Earth-like exoplanets. These worlds, with their protective ice shells and stable oceans, might be the perfect places for life to take hold. It's a reminder that habitability isn't just about being in the right place, it's about having the right conditions, even in the most unexpected environments. As we reflect on these discoveries, it's clear that our definition of habitability is expanding. Life might not need a warm, sunny planet like Earth. It could thrive in the dark, icy depths of a moon's ocean. And as we continue to explore these hidden worlds, each new discovery brings us closer to answering one of humanity's biggest questions: are we alone? But the universe isn't done surprising us yet. From icy moons to planets that defy even the most basic laws of physics, the cosmos is full of extremes. And speaking of extremes, our next discovery takes us to a world so bizarre, it makes even the coldest, darkest oceans look tame, ready to explore a planet where the rules of nature are turned upside down. Let's dive in. What if I told you there's a type of planet so light and fluffy it could float on water? Meet the super puffs, a bizarre class of exoplanets that defy everything we thought we knew about planetary density. These worlds, like Kepler 51b, are so low in density that they're more like cotton candy than solid rock or gas. Imagine a planet the size of Jupiter, but with less than 1% of its mass. It's a cosmic mystery that's left scientists scratching their heads. How do these planets even exist, and what do they tell us about the incredible diversity of worlds in the universe? Let's dive into the strange and fascinating world of superpuffs. Kepler 51b, discovered by NASA Kepler Space Telescope, is one of the most extreme examples of a superpuff. This planet, located about 2,600 light-years away, has a density so low it's almost incomprehensible. To put it in perspective, if you could somehow place Kepler 51b in a giant cosmic bathtub, it would float. But here's the twist: despite their fluffy appearance, superpuffs aren't made of cotton candy. Instead, they're thought to have thick, extended atmospheres of hydrogen and helium, giving them their low density. It's like a gas giant that's been inflated to the point of absurdity, a planetary balloon that's somehow holding itself together. So, how do superpuffs form? That's the million-dollar question. One theory is that these planets started out as gas giants, but their close orbits to their stars caused their atmospheres to heat up and expand, puffing them up like a cosmic soufflé. Another possibility is that they're the result of a unique set of conditions during their formation, where they accumulated massive amounts of gas but never developed a dense core. Whatever the case, superpuffs challenge our understanding of how planets form and evolve, showing us that the universe is far more creative and far stranger than we ever imagined. But studying superpuffs isn't easy. Their low density makes them difficult to detect using traditional methods, and their thick atmospheres obscure any clues about what might lie beneath. Scientists have to rely on indirect techniques, like measuring how much light the planet blocks as it passes in front of its star, to piece together its story. And even then, the data is often puzzling. For example, Kepler 51b's atmosphere is so thick that it's almost impossible to see through, leaving scientists to wonder what's really going on inside this fluffy enigma. The discovery of superpuffs has profound implications for our understanding of planetary diversity. These worlds remind us that planets can exist in forms we never thought possible, from dense, rocky worlds to light, fluffy giants. They also raise fascinating questions about the potential for life. Could a superpuff have a solid core beneath its puffy atmosphere? And if so, could that core support life? It's a tantalizing possibility, and one that keeps astronomers searching for answers. But as we marvel at the mysteries of superpuffs, let's not forget the role of technology in these discoveries. From the Kepler Space Telescope to advanced modeling techniques, our ability to detect and study these unusual worlds is a testament to human ingenuity. And speaking of technology, our next discovery takes us to a groundbreaking tool that's revolutionizing how we explore the cosmos. A tool that's not just helping us find planets, but also uncovering their secrets in ways we never thought possible. Ready to dive into the role of artificial intelligence in exoplanet research? Let's go! What if I told you that some of the most groundbreaking discoveries about alien worlds aren't being made by humans but by machines? That's right, artificial intelligence, or AI, is revolutionizing the way we explore the cosmos, turning the hunt for exoplanets into a high-tech treasure hunt. From sifting through mountains of data to spotting patterns too subtle for the human eye, AI is becoming an indispensable tool in the search for distant worlds. But how exactly is AI transforming exoplanet discovery, and what does it mean for the future of space exploration? Let's dive into the fascinating world of AI and its role in uncovering the secrets of the universe. The challenge of finding exoplanets is immense. Missions like NASA Kepler and TESS have collected vast amounts of data, billions of data points from millions of stars. For humans, analyzing this data manually would be like trying to find a needle in a cosmic haystack. That's where AI comes in. Machine learning algorithms, a type of AI, are designed to process and analyze data at incredible speeds, identifying patterns and anomalies that might indicate the presence of a planet. These algorithms can sift through years of observations in a fraction of the time it would take a human, making the search for exoplanets faster and more efficient than ever before. One of the most exciting examples of AI in action is its role in reanalyzing Kepler data. After the Kepler mission ended in 2018, scientists turned to AI to comb through its archives, looking for planets that might have been missed. The results were astonishing. In 2018, researchers used a neural network, a type of AI modeled after the human brain, to identify 2 new exoplanets in the Kepler data. One of them, Kepler 90I, was particularly intriguing. This rocky planet, located about 2,500 light-years away, orbits a star with 7 other planets, making it the first known 8-planet system outside our solar system. Without AI, this discovery might have remained hidden in the data for years. But AI isn't just about finding new planets, it's also improving the accuracy of detection methods. Traditional techniques like the transit method can sometimes produce false positives, mistaking stellar activity or instrument noise for a planet. AI helps filter out these false signals, ensuring that the planets we detect are real. For example, in 2019, researchers used AI to confirm the existence of Kepler 80G, a small, rocky planet in a 6-planet system. By analyzing the star's light curve with machine learning, they were able to rule out false positives and confirm the planet's existence with greater confidence. The impact of AI goes beyond individual discoveries. It's also helping us understand the broader picture of planetary systems. By analyzing data from thousands of exoplanets, AI can identify trends and patterns that reveal how planets form and evolve. For instance, AI has been used to study the relationship between a star's composition and the types of planets it hosts, shedding light on the conditions that might lead to Earth-like worlds. This kind of big-picture analysis would be nearly impossible without the power of AI. But perhaps the most exciting part of this story is what it means for the future. As AI technology continues to advance, its role in exoplanet discovery will only grow. Imagine a future where AI-powered telescopes scan the skies in real time, instantly identifying new planets and even analyzing their atmospheres for signs of life. It's a vision that's closer than you might think, and it's one that could transform our understanding of the universe. So, as we marvel at the incredible discoveries made possible by AI, let's also reflect on what they mean for the search for life. Every new planet brings us closer to answering one of humanity's biggest questions. Are we alone? And speaking of life, our next discovery takes us to a world that challenges everything we thought we knew about where life can exist, a place so extreme, it makes even the most advanced AI discoveries look tame. Ready to explore a planet where the potential for life might exist in the most unexpected of places? Let's dive in. What if I told you there's a type of planet where the skies are filled with hydrogen and the surface is a vast, endless ocean? These aren't just any worlds, they're Hycian planets, a new class of exoplanets that could be the ultimate frontier in the search for life. Imagine a planet where the atmosphere is thick with hydrogen, and beneath it lies a global ocean so deep it could stretch for hundreds of kilometers. It's a place where the rules of habitability are rewritten, and the potential for life takes on a whole new meaning. So, what exactly are Hycian planets? And why are they sparking so much excitement in the search for extraterrestrial life? Let's dive in. Hycian planets are a fascinating blend of 2 extremes, hydrogen-rich atmospheres and vast oceans. The name itself comes from combining hydrogen and ocean, and it perfectly captures their unique nature. These worlds are thought to be larger and hotter than Earth, with thick atmospheres dominated by hydrogen gas. But beneath those skies lies something extraordinary, a global ocean that could cover the entire planet. It's a scenario that sounds like science fiction, but recent discoveries suggest that Hycian planets might be more common than we ever imagined. What makes Hycian planets so intriguing is their potential for habitability. On Earth, life thrives in water, and the presence of liquid water is one of the key ingredients for life as we know it. Hycian planets take this idea to the extreme, with oceans that could dwarf even the deepest seas on Earth. But here's the twist: these oceans aren't like ours. They're likely under immense pressure, with temperatures and chemical compositions that are far more extreme. Yet, despite these challenges, scientists believe that life could still find a way to thrive in these alien oceans. One of the most exciting aspects of Hycian planets is their atmospheres. Hydrogen-rich atmospheres are excellent at trapping heat, which could create stable, warm environments even on planets far from their stars. This means that Hycian planets could exist in a much wider range of orbits than traditional Earth-like planets, expanding the search for habitable worlds. In fact, some Hycian planets might even orbit red dwarf stars, which are smaller and cooler than our Sun, but make up the majority of stars in the galaxy. This opens up a whole new frontier in the hunt for life beyond Earth. But studying Hycian planets isn't easy. Their thick atmospheres make it difficult to observe their surfaces directly, and their extreme conditions pose challenges for traditional models of habitability. Scientists have to rely on indirect methods like analyzing the light that filters through their atmospheres to piece together their stories. Even then, the data is often complex and hard to interpret. But with new tools like the James Webb Space Telescope, we're getting closer to unraveling the mysteries of these ocean-covered worlds. The discovery of Hycian planets has profound implications for our understanding of the universe. These worlds challenge our assumptions about where life can exist and expand the possibilities for habitability. They remind us that the universe is full of surprises and that life might thrive in environments we once thought impossible. From hydrogen skies to endless oceans, Hycian planets are a testament to the incredible diversity of worlds in the cosmos. But as we marvel at the possibilities of Hycian planets, let's also reflect on what they mean for the future of space exploration. Every new discovery brings us closer to answering one of humanity's biggest questions. Are we alone? And as we continue to explore, each new world, whether it's a Hycian planet or something even stranger, reshapes our understanding of the universe and our place within it. Speaking of reshaping our understanding, our next discovery takes us to a world that defies even the most basic laws of physics. A place where the rules of nature are turned upside down. Ready to explore a planet where the impossible becomes possible? Let's dive in. What if I told you that the key to finding a habitable planet might not lie on the planet itself, but on the star it orbits? That's right, a star's temperament, its flares, radiation, and overall activity can make or break a planet's chances of hosting life. Take Proxima Centauri, for example. This red dwarf star, the closest star to our Sun, is home to Proxima Centauri B, a rocky planet in the habitable zone. Sounds promising, right? But here's the catch. Proxima Centauri is a cosmic firecracker, unleashing violent flares that bombard its planets with radiation. These flares are so powerful that they could strip away a planet's atmosphere, leaving it barren and lifeless. So, what does this mean for the search for habitable worlds? And how do we navigate the challenges of stellar activity in our quest to find life beyond Earth? Let's dive in. Stellar activity like flares, coronal mass ejections, and ultraviolet radiation plays a huge role in determining whether a planet can support life. On one hand, a star provides the energy and warmth needed for liquid water and potentially life. But on the other hand, too much activity can be deadly. Proxima Centauri's flares, for instance, can release energy equivalent to thousands of atomic bombs, blasting its planets with X-rays and charged particles. For a planet like Proxima Centauri B, this means constant bombardment, which could erode its atmosphere over time. Imagine trying to build a life-sustaining environment on a planet that's constantly under siege. It's a cosmic balancing act that's hard to win. But Proxima Centauri isn't the only star with a fiery temper. Red dwarfs, the most common type of star in the galaxy, are notorious for their frequent and intense flares. These stars are smaller and cooler than our Sun, but their flares can be hundreds of times more powerful. This poses a challenge for planets in their habitable zones, which are much closer to the star than Earth is to the Sun. While these planets might have the right temperatures for liquid water, they're also more vulnerable to the star's outbursts. It's a reminder that habitability isn't just about being in the right place, it's about surviving the star's mood swings. So, how do we assess a star's impact on its planets? One key factor is the star's magnetic activity. Stars with strong magnetic fields tend to produce more flares and radiation, which can strip away a planet's atmosphere or bombard it with harmful particles. Scientists use telescopes like NASA's TESS and the Hubble Space Telescope to monitor stellar activity, measuring everything from flare frequency to ultraviolet output. By studying these factors, they can determine whether a planet has a fighting chance of maintaining a stable atmosphere and potentially life. But here's the twist: not all stellar activity is bad. In fact, some level of activity might be necessary for life. Ultraviolet radiation, for example, can drive chemical reactions that produce the building blocks of life, like amino acids. And flares, while destructive, can also provide energy for photosynthesis, like processes on planets with the right conditions. It's a delicate balance: too much activity, and a planet becomes uninhabitable; too little, and it might lack the energy needed for life to thrive. This complexity makes the search for habitable worlds even more fascinating and challenging. The study of stellar activity has profound implications for exoplanet research. It forces us to rethink what makes a planet habitable and pushes us to develop new tools and techniques for assessing a star's impact on its planets. For example, future missions like the James Webb Space Telescope will allow us to study the atmospheres of exoplanets in unprecedented detail, giving us clues about how they're affected by their stars. And as we continue to explore, each new discovery brings us closer to understanding the intricate dance between stars and their planets. But as we grapple with the challenges of stellar activity, let's not forget the bigger picture. Every star and planet we study adds another piece to the puzzle of habitability, helping us refine our search for life beyond Earth. And speaking of refining our search, our next discovery takes us to a groundbreaking tool that's revolutionizing how we explore the cosmos, a tool that's not just helping us find planets, but also uncovering their secrets in ways we never thought possible. Ready to dive into the future of exoplanet research? Let's go! What if I told you that the most exciting chapter in the search for alien worlds hasn't even been written yet? The discoveries we've made so far, from diamond planets to ocean moons, are just the beginning. The future of exoplanet exploration is brighter than ever, with groundbreaking missions and technologies on the horizon that promise to revolutionize our understanding of the cosmos. From telescopes that can peer into the atmospheres of distant worlds to instruments capable of detecting the faintest signs of life, we're on the brink of a new era in space exploration. So, what's next, and how will these advancements bring us closer to answering the ultimate question? Are we alone? Let's dive into the future of exoplanet exploration. First up, meet the Nancy Grace Roman Space Telescope, set to launch in the mid-2020s. Named after NASA's first chief astronomer, this telescope is designed to tackle some of the biggest questions in astronomy, including the search for Earth-like planets. Unlike its predecessors, Roman won't just look for planets. It will map the galaxy in unprecedented detail, using a technique called microlensing to find worlds that other telescopes might miss. Imagine being able to detect planets thousands of light years away, including rogue planets drifting alone in the void. Roman's wide-field view and advanced optics will give us a clearer picture of the diversity of planets in our galaxy, from rocky super-Earths to icy giants. But that's not all. Roman will also study the atmospheres of exoplanets, searching for biosignatures like oxygen, methane, and water vapor. It's a mission that could bring us one step closer to finding a world that's truly Earth-like. Then there's the Extremely Large Telescope, or ELT, currently under construction in Chile's Atacama Desert. When it's completed in the late 2020s, this behemoth will be the largest optical telescope in the world, with a mirror nearly 40 meters across. That's 4 times the size of today's largest telescopes. With its incredible light-gathering power, the ELT will be able to study the atmospheres of exoplanets in stunning detail, analyzing their chemical compositions and even mapping their weather patterns. Imagine being able to see clouds, storms, and maybe even continents on a distant world. The ELT will also play a key role in the search for biosignatures, giving us the tools to detect signs of life on planets light years away. It's a game changer in every sense of the word. But the future of exoplanet exploration isn't just about big telescopes, it's also about new techniques and technologies. Take, for example, the development of starshades, giant space-based structures designed to block out the light of a star, allowing telescopes to directly image its planets. These starshades could revolutionize our ability to study Earth-like worlds, giving us a clear view of their surfaces and atmospheres. And then there's the growing role of artificial intelligence, which is helping scientists sift through mountains of data to find planets that might otherwise go unnoticed. From machine learning algorithms to advanced modeling techniques, AI is becoming an indispensable tool in the hunt for alien worlds. As we look to the future, it's impossible not to reflect on how far we've come. Just a few decades ago, the idea of finding planets beyond our solar system was pure science fiction. Today, we've discovered thousands of exoplanets, each one a testament to the incredible diversity of the cosmos. From scorching hot Jupiters to icy ocean worlds, these discoveries have reshaped our understanding of the universe and our place within it. They've shown us that planets are everywhere, that the conditions for life might be more common than we ever imagined, and that the search for life is far from over. So, as we stand on the brink of this new era of exploration, let's take a moment to marvel at the journey so far. From the first detection of 51 Pegasi B to the tantalizing possibilities of Hycian planets, each discovery has brought us closer to answering the ultimate question: are we alone? And with missions like the Nancy Grace Roman Space Telescope and the Extremely Large Telescope on the horizon, the future is full of promise. The next chapter in the search for alien worlds is about to begin, and it's going to be extraordinary. So stay curious, keep exploring, and remember, the universe is full of surprises and the best is yet to come. What if I told you that in just a few decades, we've gone from wondering if planets exist beyond our solar system to discovering thousands of them, each one a window into the incredible diversity of the cosmos? From scorching lava worlds to icy moons with hidden oceans, the 25 greatest discoveries about alien worlds have reshaped our understanding of the universe and our place within it. These aren't just distant dots of light, they're stories waiting to be told, mysteries waiting to be unraveled. And as we stand on the brink of a new era in space exploration, it's worth taking a moment to reflect on how far we've come and where we're headed next. Think about it, just over 25 years ago, the idea of finding planets around other stars was purely theoretical. Then came 51 Pegosi B, the first exoplanet ever discovered orbiting a sun-like star. That single discovery opened the floodgates, proving that planets are everywhere. Fast forward to today, and we've found worlds that defy imagination: diamond planets, rogue planets drifting alone in the void, and even planets with 3 suns in their skies. Each discovery has challenged our assumptions, expanded our horizons, and reminded us that the universe is far stranger and more beautiful than we ever imagined. But these discoveries aren't just about cataloging distant worlds. They're about answering some of humanity's biggest questions. Are we alone? What does it take for a planet to support life? And what does the future hold for our species as we reach out into the cosmos? The answers are still out there, but every new discovery brings us closer. Missions like the James Webb Space Telescope and the Nancy Grace Roman Space Telescope are poised to revolutionize our understanding of exoplanets, giving us the tools to study their atmospheres, map their surfaces, and even search for signs of life. The future of space exploration is brighter than ever, and the possibilities are endless. So, what's next? Imagine a future where we're not just observing distant planets, but actively exploring them. Where we're sending probes to nearby star systems, studying the atmospheres of Earth-like worlds, and maybe even finding evidence of life beyond our own. It's a future that's closer than you might think, and it's one that we're all a part of. Every discovery, every mission, every question we ask brings us closer to unlocking the secrets of the universe. But here's the thing, the journey isn't just for scientists and astronauts, it's for all of us. Whether you're a space enthusiast or just someone who's curious about the cosmos, you're part of this incredible story. So let's keep exploring together. Share your thoughts in the comments below. What discovery about alien worlds fascinates you the most? Don't forget to subscribe and hit that notification bell so you never miss an update as we continue this journey of discovery. And most importantly, stay curious. The universe is full of surprises, and the best is yet to come. As we wrap up this exploration of the 25 greatest discoveries about alien worlds, let's leave with a sense of wonder and anticipation. The cosmos is vast, mysterious, and endlessly fascinating, and who knows, the next groundbreaking discovery could be just around the corner. So keep looking up, keep asking questions, and keep dreaming of the possibilities. The universe is waiting, and the adventure is just